I'm Professor Pi. Welcome to my daily mathematical adventures. Hey, don't forget me. I'm Cowboy Rufus. I'm your favorite student. Today, you might as well put those calculators down because we're going to talk about imaginary numbers. There's a whole imaginary number system you've never seen before, but the calculators won't help because the calculators only solve for real numbers. Today, we're going to talk about imaginary numbers. This is complex imaginary numbers. It's algebra 2 NQB.5 and A2 NQA.4. I can perform operations with pure imaginary numbers. I can perform operations with complex numbers. 3 videos here besides mine. Mine will go up here when we're done with this video. This is the imaginary number. The square root of 16 is 4. The square root of 2 is 1.4 something. We never knew what to do with the square root of -1, so we made it I for imaginary, I for made up. So the square root of -1 is I. So I squared, of course, would be -1. Then we have a whole chart here what to do with the i's. I to the first power is just I to the second power is -1. I to the third power would be minus I, because it's -1 times I, and I to the fourth power would be -1 times -1, which is 1. And here's what happens 1 through 12. 5 divided by 4 is the same as 1, so it would be I. 6 divided by 4 has a remainder of 2, so it would be the same as in that column. If it's divisible by 4, it's 1. If it's divisible by 2, it's -1. Divisible by 3, it's minus I. And divisible by just one remainder, it would be I. That comes across now, we have complex numbers. I to the 6th times I to the 7th is I to the 13th. We can go back up and look. That one's pretty easy. I to the 13th, 13 divided by 4 is going to be right up here again. It's going to be I. A complex number, we're going to make it a little bit harder. We're going to put a complex real number in with an imaginary number. 5 plus 3i and 6 plus 7i. When you add them, you add the real part. You add the real part and you add the imaginary part. So what we get here is 11 plus 10i. And once again, we can figure out what 10i is. 10i would be 4 divided into 10 has a remainder of 2. If it has a remainder of 2, it becomes -1. So this would be the same thing as 11 plus 10i. It's not 21 anything. And it's not I squared, it's not I cubed, it's not I to the 10th, so we can't do what I just did up here. That's not what that chart's for. We have 11 plus 10i. That's our addition. We could subtract them. You would just subtract both of the bottom numbers, and you would get -1, -4i. Still nothing you can do. You must leave the I all alone if it's just one I. You can multiply them, so we'll try and FOIL them. First, 5 times 6, 30. Outer, that's plus 35. I plus 35 I. Inner plus 18i. And last, 7i times 3i is 20 plus 21i squared. Now we know what to do with I squared. I squared is -1. So let's just make it in combined like terms. We get 30 minus that 21 plus 35i plus 18i. And now once again, we just continue combining like terms. We get 9 plus 53i. 9 plus 53i is what you get when you flow that first, outer, inner, last. Now, the next question, if we can multiply and you can add and subtract, the next question you might worry about is, can we divide? We can simplify the division. That is, we don't want any i's on the bottom. They define simple as no i's on the bottom. It doesn't look simpler to a lot of people, but that's how they define it. So then we need a conjugate. If there's a 6 plus 7i, somewhere there's also a 6 minus 7i. And when you multiply the two together, it's the difference of two squares. You only get two terms. You don't get three terms, and there won't be an I term. So when we have division, there's our division problem right there. We're going to multiply by the conjugate of the bottom number. 6 plus 7i, we're going to multiply by 6 minus 7i over 6 minus 7i. And it's an identity. It's equal to 1. So when we multiply by it, we're not changing anything. So we're allowed to do that. So 6 minus 7i, we're going to multiply that first, outer, inner, last. We get 30 minus 35i plus 18i plus 21i squared. First, 5 times 6, I got it. Outer, 5 times minus 7, I got it. Inner, 3i times 6, I got it. So that's what we get on the top. And then we simplify that. We get 30 minus 17i minus 21. Eventually, we get 9 minus 17i on the top. But the top's not what we worried about. We worried about simplifying. So let's look at the bottom. When we multiply 6 plus 7i times 6 minus 7i, we get 36 minus 7i squared. The middle terms leave because the middle terms are minus 42i and plus 42i, and they will leave. We do know what's something about I squared. I squared becomes negative. Negative times negative 49 is a plus 49. So we get 36 plus 49 on the bottom. We add that up and we get 85 on the bottom. The conjugate helped us simplify the division problem because they don't want any i's or any radicals on the bottom. That's how your book is chosen to simplify. So we can add, subtract, multiply, and divide these complex numbers. We're going to go to IXL Algebra 2, I, 1 and 2, and I want to work the first 3 or 4 that you think are hard, so let me get them on the board, and we'll work them. Once again, what you need to know today is the square root of minus 1 is I, so the square root of minus 16 is 4i. Very good. What would be the square root of minus 25? Be 5i. Very good. So I equals the square root of minus 1, and I squared equal minus 1. And once again, these are imaginary numbers. You will not find these keys on your calculator. They are not real numbers. Everything you've had till now was real. Rational, irrational, real. Fractions, Q, part of real. Integers, part of real. Now we have imaginary and complex numbers. They are not members of the real number system because if you look at your calculator, they don't have real keys. Thanks for watching another Professor Pi video. Yeah, y'all come back tomorrow. Cowboy Rufus and Professor Pi will teach you something new.